Hello everyone, let's try and solve another problem. In the range 0 less than or equal to x less than 2 pi, the equation 3 plus cosine x squared equals 4 minus 2 sine to the 8x has 0, 1, 2, or 3 solutions. Okay, so I've done a similar problem to this not too long ago, and I'm going to use more or less a similar idea, or am I? I mean, what I'd like to do is think of this as being a polynomial equation with respect to a trigonometric function of x. But I'm not seeing exactly. Okay, so let me write this out and then expand things and show how we can view this as being a polynomial with respect to a trig function. So the first thing I'm going to do is I don't want to see both cosine and sine all over the place. So I'm going to replace the sine to the 8x. This can be written in terms of cosine x. I'll also expand the left-hand side because I think that it'll be nicer to have this written out in terms of cosine x. Now that I do this, this actually looks pretty nasty because I'm going to have, cosine x raised to the power of 8 here. So maybe a better way of doing this is to and it doesn't look like I'm going to have any simplifications or cancellations like if the constant linear and quadratic term in cosine x somehow disappeared from this completely, that might help, but I don't think that's going to happen. Maybe instead I should look at this and think of what possible ranges the thing on the left and the thing on the right could take on. Let me think for a moment. Okay, so here's something we note. By realizing that cosine x is bounded between -1 and 1, 3 plus cosine x is bounded between 2 and 4, and so 3 plus cosine x squared has to be between 4 and 16. On the other hand, on the right-hand side, sine x to the power of 8 is always between 0 and 1. And so 4 minus 2 times sine x to the 8 has to be between 2 and 4. So this means that these two quantities can only be equal. This quantity here can only be equal to that quantity there if they're both equal to 4. Okay, so let's see what we get here. Well, immediately from this tells us that sine of x has to be equal to 0. And this tells us that x has to be equal to 0 or x is equal to pi because, I didn't write it down originally, but in the original statement of the question, x is greater than or equal to 0, but strictly less than 2 pi. So the only values of x that allow this to happen are 0 or pi. So on the left-hand side, if I substitute x equals 0, I get 16, so that doesn't work. And if I substitute x equals pi, cosine of pi is -1, so that's 4. Okay, so this does work. And so not only do we know how many solutions there are, but we know that the only solution to this thing is x equal pi. Yeah, my first instinct here happened to be something that would have turned into a mess, right? Treating this as an algebraic equation rather than trying to do analysis Maybe it's possible, but did not look nice. I suppose seeing something raised to the 8th power should have been an indication to me that any straightforward algebra probably wouldn't work. You know, we basically have an 8th degree polynomial in cosine x written here. There's not going to be much hope of figuring out anything about the roots, at least not without a whole bunch of other advanced stuff, which I don't think is reasonable to expect someone writing this test to know. Yeah, but also understanding that for real values of x, cosine and sine are bounded between -1 and 1. Just kind of allowed me to eventually figure out that there is a big restriction on you know, potential values of x by knowing that the only way for these things to be equal is when they're both equal to 4. And then we can solve for x directly. Yeah, so pretty cool problem. If I find a mistake or if I have anything more to say about it, I'll put it down in the description. Otherwise, thanks for watching.